Hello to you. My name is Jessie Johnson. This is the sun. How large is the real sun approximately? Our sun is not very large for the extreme heat and extreme brightness it puts out. The heliocentric religion model of the universe is about 97% false. To tell how large the real sun is takes only a few simple things. To begin, we'll start with A. The surface of the earth we live on is 100% flat, water-wise. A ball-shaped earth is physically impossible using true centripetal force, and gravity as it is conceptualized is illogical and impossible and do not exist. B. About 2,000 years ago, a mathematician did a simple experiment with two sticks in the ground, distanced 500 miles apart. This was to suggest that the earth was ball-shaped. What he proved was that the sun is less than 500 miles in radius and only a few thousand miles above the earth's surface. One stick had no shadow at 12 noon and the other stick, 500 miles away, had a shadow at 12 noon at the same time of year. We'll go to C. Our small sun is 2,850 to 4,950 miles above the earth's surface in its actual circuit. This is 100% proved by the use of very basic trigonometries, angle of elevation. We'll use the equator's circumference as an example for the sun's general circuit. Hold on please, I'm going to turn the camera around. Now, to continue. Once again, we'll be using the equator. The equator here. The equator is 24,901 miles in circumference. Divided by 24 hours equals 1,040 miles per hour. Divided by 60 minutes equals 17 miles a minute, which equals 17 times 5280, that's 1 mile, which equals 89,760 feet, which is divided by 60 seconds equals 1,525 feet a second. It is 11:59 a.m. and 59 seconds. That means it is 1 second before 12 noon. This here is a right angle triangle. Right angle triangle. The fifth 1,525 feet is put here, down here, and this is the hypotenuse side of the triangle, the opposite side of the triangle, and the adjacent side of the triangle. This is Earth at the bottom here, and up there at A, B, C is the sun at C. Now, since it is a 90-degree triangle, and you have only 1 single second to go 1,525 feet, it is put 89.99 degrees, only a small amount before 90 degrees. So therefore, A to B is 1,525 feet. A to C is 89.99 degrees. That's degrees, even though I don't have the little thing up there, it's 89.99 degrees. And B to C is 15,250,000 feet divided by 5,280 feet, which is 1 mile, equals 2,888 miles. It is 2,880, the sun that is 2,888 miles above the Earth's surface at 11:59 at 12 noon. And this is the using of basic trigonometries, angle of elevation. Now, I'm going to do a few things with a wooden yardstick here. This yardstick is, let's see now, oh here we go, is 1 inch, where 1/2 inch equals 50 miles. 1 inch equals 100 miles, and we have a 30 inches here, 30 inches, that's equal to 3,000 miles, or 30 times 100. And these two cards, business cards right here, is glued to the back of the yardstick. Pardon me, not glued, but taped to the back of the yardstick here. And there is a slit, a small slit between the cards, right here. A small slit between the cards. What does that mean? It means that I've already measured the sun. Now, the sun is way up here, 3,000 miles approximately above the Earth's surface up here. If I can get it up in there. And this here measures the size of the sun. Let me see if I can get the sun in between that baby. Let's see, here we go. There it is. There it is. There it is. There it is. The sun is approximately between 6 and 7 miles wide on the little slit right there. The slit, the small slit right here, the small slit, the 1/2 inch, which equals 50 miles, has four divisions. So 4 into 50, 4 into 50 goes 12.5. So the sun is approximately about half that, roughly about 7 miles across. Now, the thing about this is that the sun can look larger or smaller, depending on how close it is to you. And we see the sun, almost every day of our life. I've seen the sun a maximum of about 6 times larger than I see it today. So whatever result I get, in other words, the wooden stick I've just shown you, it cost me $1. And it is a simple way to find the sun's general size. Once again, 1/2 inch equals 50 miles, 1 inch equals 100 miles, and 30 inches equals 3,000 miles, or 100 times 30. Now, the two business cards are taped to the back of the yardstick, and I've already measured the sun with it, and therefore have a gap between the cards approximately the size of the sun. The sun is about 1,900 to 2,000 miles away from me. Given this time of day and my shadow's length and the season, and about 3,000 miles above me. Now, the sun can look larger or smaller depending on how close it is to you. And we see the sun almost every single day of our life, and I've seen the sun a maximum of about 6 times larger than I see it today. So whatever result I'm going to get with this, I'll multiply it by 6 to get an approximate size. On the yardstick, 50 miles has 4 divisions. As you can see, 4 divisions. Every 1/2 inch has 4 divisions up in there. And 50 divided by 4 is 12.5 miles. 12.5 miles times 6 is 75 miles. Since I measured the sun is measured here, is about 7 miles in diameter. So 7 times 6 is about 42. So therefore the sun, the real sun, is between 36 miles and 40 miles. Pardon me, 36 miles and 42 miles in diameter, as far as I can tell. So, but we will, what we'll do is round it off at 40 miles. That's what we'll do. Now, we'll round it off at about 40 miles. See, the sun illuminates between 1/3 to 1/2 of the Earth's surface, flawlessly and exactingly, every single second, while it is moving 1,525 feet a second to 44,400 feet a second on its path. So it moves 1 mile in about every 3 to 3.5 seconds, and about 50 miles in about 150 to 175 seconds, or close to 3 minutes. Now, some people will find that a 36 to 40 mile diameter for the sun is too small to cover this much surface with light and heat. But this isn't too small, and I consider it not the case at all. Now hold on. I want you to look at this for a quick second. Now, this is a room. It is 50 miles wide, 50 miles square, you know, a regular room, 50 miles square, and it is 25 feet high. So therefore, you have a light bulb. This is a light bulb, and it represents the sun. It is 400 watt light bulb, and it is 4 inches in diameter, which goes to this here. Since the sun is 3,000 miles up, approximately that is, 1,000 miles above the Earth's surface, divided by 40 miles equals 75. Now, like I said, the bulb is 4 inches. So 4 inches times 75 is 300 inches. And 300 inches divided by 12 inches, that's a divide sign, not a minus. 300 inches divided by 12 inches equals 25 feet. That's where you get the 25 feet, and I use 25 feet this way and 25 feet that way to get the 50 feet. Now, the light, 1 watt equals 1 heat unit. That's an HU. And the light bulb is 400 watts. But what happens if you have this size room with a 400 watt light bulb? It would be pretty dim inside. But what happens if you multiply the 400 watts times 200, which would equal 80,000 watts in the same small little space above? That's a lot of lumens. That's L-U-M-E-N-S. That's how you measure brightness. And that would be extremely bright. And as far as the heat goes, it would be, since 1 watt equals 1 heat unit, it would be 400 watts equals 400 heat units. And that means 400 heat units times 200 also equals 80,000 heat units. That would be extremely hot inside this small area. But the sun, unlike this bulb which stays fixed, the sun instead moves in its circuit, spreading the heat as it goes along its path. Now, I want to thank everybody for listening and watching. Please share this video and have a good day. Oh yes, to see all of my videos, write Jessie Johnson into YouTube, Jessie into YouTube, and my face will come up inside of a round, a circular inside of a circle with dark green trees in it. Now I want to thank everyone again for watching and listening, and please have a very fine day.